My name is Bob Tickleman, and I'm excited to be your guide for learning path number 2, Implement Azure Functions, part of the AZ-204 course. Azure Functions are going to be split up into 2 recordings where we're going to explore what an Azure function is, and then we're going to develop an Azure function itself and show you the characteristics of the function process. Module 1 explores the Azure function as an overall container object. It's not the code. Remember, we've talked about this in other recordings, that this course is not about actually writing function code. It's about what an Azure function does as a container object in which your code, the actual function that you want to perform, exists within this feature called an Azure function. So let's see what this is going to do for us. In previous recordings, we talked about the runtime environment in which your application, your code runs in. And we've described other environments, whether they be IaaS or infrastructure as a service or PaaS offerings, platform as a service. Now, an Azure function you can see exists as a specific type of environment that could run in some of them or as a standalone feature. And so I want to do a small whiteboarding session to talk about where an Azure function might fit in your overall application development. And then we'll come back and take a look at this feature called an Azure function, and we'll give you an example of the type of code that might live inside of it. In a previous recording, we talked about modern application development. And when we start looking at microservice applications, we now have a model that looks very similar to what I've got on the screen, where my network is broken up into 3 segments, or a segmented network, where I've got my front end, my middle tier, and my back end. We segment these environments, but each application is a standalone unit of an application that might be, in this case, a web app. In the front end for my website, if you see, we had a whole module that talked about app service plans and web apps that might exist in there. For me, Azure Functions become the dark matter. If you were an astrologist, we've got planets that exist in the universe. Those are like our applications. These are the core features that your application are going to perform. And so your website, your shopping cart, your backend database or system of record, these are major components of your overall microservice application infrastructure. And for me, Azure Functions provide this, as I said, dark matter. It's the space between your big planets. Because maybe I could write that thing inside of the application itself, or I'm going to give you an example of a thing called a LUN algorithm that I'm going to use as a function that I may want to consider. So through my process, I've got a website that users can come to. They could search for my products. They could possibly put something in a shopping cart, which is another form of my application. And then I have to store that information durably somehow. And we'll take a look at other recordings that will show you how to be able to store that information in a longer term period other than the memory of the volatile space of the application you're working with. Now I'm going to make a leap down here, and I'm going to say that eventually somebody's going to want to buy the items in their shopping cart. So I'm going to have a whole process, and I could write a very large application, and you'll see what this might look like in a few minutes, that will actually go through the order verification, validating all the information about the products that you've ordered and checking to make sure that the ship to and the billing information is all correct. And what I want to do is I want to make sure that the credit card information that you've given me is going to be valid. Now, I could just take that credit card number as a valid input and try and send it off to the credit card processing company only to have it rejected because maybe you put in and transpose 2 numbers. Maybe you select Visa when it's a MasterCard. All of those things. I love doing this myself. I go to websites and I always find it interesting when they ask me, tell me what kind of card you've got, and then give me the credit card number. And I'm wondering why they don't do what I'm about to describe to you. So it's not going to be part of my application. I'm going to create an Azure function that is going to validate a credit card. Now, there's a thing called the LUN algorithm that was developed back in the 1960s to do validated input on a value. And it could check this number to make sure that it's a correct number. So that at the time of input, I can tell you, hey, I think that this is an incorrect number. Please check it and re-enter it. The other thing it can do is it can tell you where that number came from. If it's a thing like a credit card, or in the case of a national identity, I'm going to use the example of a Canadian social insurance number for the check of not only is it valid, but where did it come from? So I'm going to write a LUN algorithm to take the input value that was coming from the shopping cart, and as part of my order verification, I'm going to verify as a function that value to make sure that I don't process a credit card that has a wrong value, and thereby making my application for order fulfillment not work. Now, I'm just going to go through and show you some of these background pieces before we get in and show it to you in the portal. So the LUN algorithm talks about this mathematical formula that takes an input value, runs it through this mathematical formula, and tells you whether it's valid or not. And what it does, it takes, in this case, an input value of 799,273,9871. It multiplies it by 21212, does this math calculation on it. 2 times 7 is 14. 4 plus 1 makes 5. 2 times 9 is 18. 8 plus 1 is 9. 1 times 2 is 2. That makes 2. And this should always come up into a rounded 10-digit number. As I said, it can be used for a whole variety of things, from determining national identities, and it's used extensively in the credit card numbering system. Now, just using my example, not only can it tell me, is this an input value that's correct? So I'm going to a social insurance number in Canada. It will then take that number. So here's my Azure function. I'm going to take an input value, going to run it through this Azure function to make sure that it's valid. And if it's not, I'm going to then send it back to you before I say, here's your order, thank you very much. I will now go through order fulfillment for you. And it's going to do that 12121. It's going to come up into, in this case, a rounded 10-digit number of 40. That output number is then going to be able to tell me where that number came from. In this case, it came from the province of Ontario. That same model can be used for credit card numbers. I can validate that long number that you've given me, that yes, it's a valid number, and I could tell you it's a Chase Visa or a Bank of America Visa, a MasterCard. So all of these things we can then use as part of our order processing model. One of the things that you'll see in the book, an Azure function has a one-to-one feature between a thing called a trigger or an initiating activity. One Azure function can have one and only one thing that kicks it off. Now, this is going to be a tight control. There's another thing called a Logic App that now can have up to 10 input triggers that initiates the Logic App. Now, they can be considered to be very similar. We don't cover Logic Apps in this recording, but it is a low-code, no-code environment that provides a more complex set of if-then-else statements that you're working with, and you can drag and drop the features in. So, for example, you might sit there and say, I need to be able to check for social media posts for a kind of information. You could drag in a social media connector for that social media platform. It'll ask you, based around the APIs, what the authentication credentials are, and then what do you want to search for on the subject line or the description or in the body of the post itself. All of that can be done through a thing called a Logic App with up to 10 triggering activities. An Azure function should be really considered like a sports car. It's got one a highly tuned feature. It's not just a sports car, it's actually a race car, which is different from a Formula One versus, say, Daytona, the kind of setup and the capabilities it can do. So an Azure function has a one-to-one activity. It has one triggering activity. And while it can connect to a variety of sources for inbound and outbound, all this is going to come up on a slide, the initiating activity is one and only one activity. So in our case, somebody putting an input value in of a credit card number is going to be the initiating activity that calls the Azure function. The Azure function is then going to go through the LUN algorithm, and it's going to calculate, is that a correct number or not? And if it's not, it's going to fire that back to your application and say that it's an input value that needs to be valid or corrected. And if it's a correct number, well, I could either say now continue processing, or maybe I want to actually do something else. Maybe I want to say, where did it come from? Now, this becomes a bit of not a hard requirement. I remember I said an Azure function does one and only one thing. So in this case, my Azure function is going to check to see if it's a valid number. I theoretically could also have my Azure function also tell me where it came from. But in my world, that's two things. And so I would have this Azure Lungen algorithm say, yes, it's a valid number, and say maybe the number is 40. I'm going to take that value, which is part of the memory of the application, in this case, my Azure function. I've got to find some way to pass that off to another Azure function that could be triggered saying, take that number 40 now and tell me where it came from. Now, this is going to be referred to as a durable function, where I have multiple functions working together to provide some response for me. So a function by itself does one and only one thing with one trigger. It can be connected for what are called bindings, multiple inputs and outputs of ways to communicate, but it's only got that one triggering activity, and it should do one thing. Now, if you want something more complex, you could create durable functions or maybe go to a logic app to work with it. So there's a small example of being able to create this thing of where an Azure function comes from and where it fits in the overall scheme of my application design, where I've got my microservices that are things that I truly need to code, where I might have something like this little algorithm that says, I don't need to put it in my code because maybe I have multiple ways for people to pay for things. And I don't always have to call the credit card validation because maybe they're using a credit that's on in their account. Maybe they're using a pay by an agreement that says they've got 30 days to pay. So I don't have to run a credit card. So all sorts of reasons to do this. I don't want to go into them at this point, but I'm in my case, in my example, I'm going to not build that in my application. I'm going to use it as a function that is called as part of my overall process that I'm working with. So before I go out to the portal and show you this is basically what I've been talking about. Is you have an Azure function that's in the center of this diagram that has this code that is going to perform some activity. It is the capability to have one triggering activity, although it can communicate both on an inbound and outbound process to any other Azure services or other services, whether through WebJobs and webhooks that you're working with. And so you can see I can have an inbound connection, something happened in a storage account that triggers an Azure function. Something happens in maybe a SQL database that triggers an Azure function that puts something output to a storage account. So all sorts of different ways. So bindings can be two ways. And a binding, if it's an inbound and it's a trigger, it can only be an inbound binding that you're working with. And you're going to see this come up in a later portion in another recording on Azure Functions that talk about the complexity of the actual configuration of the Azure function. We're just kind of setting this up. So Azure Functions, for me, as I described it, is that dark matter that sits in the universe of your applications, of the microservices in your galaxy you're working with. So you've got this galaxy of planets, your applications, that have these functions that tie these things together. We have the bindings that you're working with and that triggering activity that initiates it. Now, it could be a timed trigger that you have, or it could be some kind of event-based trigger that says on a creation of a storage account or on the creation of a blob in a storage account, I want to trigger that function that you're working with. Now, Azure Functions and Logic Apps, which I just described, kind of fall into a similar area in which you're working with. Now, there are some slight differences where Logic Apps are going to be part of an app service plan, which we covered in another recording, along with things like web applications. And function apps can also exist in an app service plan. You'll also see in a few minutes that we have other ways that they could be hosted in consumption plans and serverless environments. But you're seeing that similarity. And for me, this becomes one of those eye-winking moments that compares an Azure function versus a Logic app. The big difference is there's one and only one trigger that happens in a function, where a Logic app can have up to 10 of those triggers that you're working with. And it's giving you some other use cases for each of these environments, but very similar in their overall consideration in your application deployment and design, that they do a lot of similar capabilities. And now looking at Azure Function versus WebJobs with your WebJob SDKs, another way to be able to have these small bits of code be able to perform activities for you. And again, taking a look at it from an exam perspective, you'll see that WebJobs are not as closely aligned to Azure Functions on things that it can't do, but the types of triggers very similar. So you might get a question that says you're looking for something that provides for a timer-based trigger that is also going to support integration with Logic Apps. WebJobs don't. You get that feature with Azure Functions. When you take a look at a hosting plan, and I've alluded to that earlier in the recording, we have a variety of ways for Azure Functions, because remember, they're usually small bits of code that you might use on a regular basis or maybe used infrequently. So depending on the pattern that you have, down that left-hand side of the slide, we show that you can have a consumption plan, you can have a flex consumption plan, a premium plan. All of these different plans allow for a cost management piece, and usually looking at the speed and frequency in which you can have predictable costs on the use of the Azure function that you're going to deploy. Now, that dedicated plan falls into the app services. So in a previous recording, we talked about app services and the types of apps that you could have in the app service plan. We talked about web apps. We talked about logic apps. Function apps are one of the things that could exist, and all of the feature of the app service plan, scaling capabilities, environmental configurations that you're going to be passing through to it. All of those capabilities in that recording would then apply to it. We're going to take a look at some of the features now within the other plans, that if you have a consumption plan, only when the Azure function is being called that's when you're going to be paying for it. So if you have people that are not going to use, in my case, my LUN algorithm to check a credit card number, I don't need one running. I'm not paying for that service to be available for my application. Now, there's pros and cons of some of these as you go through it. If it's not running, you have to actually wait for that warm-up time for that application to spin up, or the function to spin up, to be able to perform that activity. Now, it might be very quick, but depending on what your response and rate is and your SLA for your application, you may want to have an instance of that always running. So you might find a different plan that meet those requirements, and those will be detailed for you as you go through the different values of the plans. So I would encourage you, there's just a quick summary on the screen that you could then use to make a determination of which plan to use to meet your business requirements. Now, I'm going to go out into the Azure portal and take a look at the creation of an Azure function. In the Azure portal, the first thing you do when you select the creation of an Azure function app, it picks which Azure hosting plan would you like to have. And it gives you some of the feature differences that would allow you to make that choice at this point. So you're taking a look at max scale out instances. So depending on the number of instances you're working with. Now remember, if you've got a large scale application that you need lots of these microservices and you're not using them extensively, this might be a great way to get a large number of instances very cost effectively for you to be able to work with it. So you can pick whichever plan you want. I'm going to come to the flex consumption plan, because in the app service plan, it would be very similar to when we, in the recording, created a web app. It's going to ask me which app service plan I want to install it. I'm not going to go through. You could see that if you take a look at that other recording. So I'm going to pick the flex consumption plan. And a lot of the same features are going to be available across all of them. The basic features is you need to have a subscription to bill it to, you have to assign it to a resource group, and then your function app name. As described with other Azure resources that are globally available, you've seen in this case, it's being appended to an Azure Websites.net name that is publicly accessible. So it needs to be then globally unique across all of Azure, not just with inside of your use of Azure inside of your tenant. Now you can see that we've got this option that now provides some uniqueness to that. So if I put in my Contoso function, you can see that it's going to add an attribute to make this globally unique, or I could create out that global uniqueness based around myself. And if you don't like this number or if you don't like this naming convention, remember that you can use DNS to take that name and make it something more consumable and readily available within your organization to use some naming standard that you're going to be working with and just manage that through DNS. Very much like many other Azure resources, an Azure function, in this case, is going to be regionally deployed. So it's regionally specific. If I need it in multiple regions, I would have to create multiple function apps to be able to do this. I'm going to come into East US 2. I then have to pick my runtime stack that I want to work with. And again, these are currently supported versions of all of these general runtimes. .NET, Node.js, Python. I'll pick some Python. And then I get currently supported version of Python that I want to deploy it across. What is the instance size? So remember that in the app service plan recording that you saw, the app service plan was the arbiter of the number of resources, the amount of memory, the amount of compute that was being allocated. Because I'm not making it part of the app service plan, I have to now control some of those capabilities to now say, what am I going to allocate to this function app itself? We talked previously about zone redundancy, and so I can either make that available or not. As with most of these, the memory that is going to be allocated is non-durable. So if the function goes away, going back to my example of if you have an Azure function that is doing a LUN algorithm against an input value, yes, it could tell you its value is valid. That's one thing. I might need to store that value. Is it valid? Yes, I need to store that. And what is the number? Because maybe I need to make that available to another Azure function, or maybe I want to keep it the number that it generated. So whatever that might be, I need to make that durable. And I need to do that in some form of storage. In this case, and we'll have a recording that we take a look at storage accounts. So whether that be an Azure table or a blob storage that I can store it in. So I can actually configure the blob storage to do that for me. I'm not going to go through all of these tabs, but we now have capabilities for Azure OpenAI. We have networking capabilities, monitoring, deployments we'll take a look at in a few minutes on after I've deployed one, as well as authentication. We mentioned that your function could connect to other bindings. And so I could connect to a storage account to see something, or I could connect to a storage account to put something there. So remember, we had an input binding or an output binding that you could work with. Well, maybe I need an identity to be able to authenticate to those extra resources. And so we have ways to be able to do some of these authentications using system assigned managed identities and key vaults, all these different characteristics in a secure application development model. So I'm going to go through and create this. Now, while this is being created, I want to show you a small example, and I've made reference to this in the introduction to the entire course, and using something like Copilot. You might hear about vibe coding, and depending on where your familiarity is with coding and or even Azure infrastructure, Copilot's going to be a great friend for you to be able to get in and work with some of these services. Now, I'm not going to go into the whole preamble prompt that I gave this one earlier that talked about using the well-architected framework and the cloud adoption framework, but I'm going to show you an example of, I want to validate a credit card number on input and determine which vendor the card was generated by or created. I understand that the LUN algorithm could help me with this. Am I working in Azure? And I think that an Azure function might be the solution for this. Would you concur that this is a great recommendation? Or do you have another method that you should use? And if you agree with this, could you maybe give me some implementation for the solution? So very quickly, I don't have to be a coder, and I don't have to know all the pieces that I've been talking about in these recordings. I could now have a small idea of what it is that I'm looking for, articulate it properly, and take a look at what it's going to come back with. It says absolutely using the LUN algorithm is the right method to do that first input checking. So I think I'm on the right track, and is an Azure function still the best way to do this? It uses an HTTP trigger for an Azure function. Is a solid way to get in and work with this. But it actually talks about some compliance features, and it says, should you use the Azure function? It says yes, and how you would set this up. But it also makes a recommendation about PCI compliance and maybe some guardrails. And it talks about, really, do you want to be managing credit card information and that private information, or do you want to have a more secure method? So it's actually going to make a recommendation around a potentially better method if you're going to do more complex processing. But if you're just checking the number, LUN algorithm is very good for this. And so what it's going to do is give me the code that you can actually drop in to be able to perform this Azure function and do the validation input. So I don't even have to be a coder. Remember, this course wasn't necessarily about coding, but using Copilot might be a great way to get in and work with this. It gives me some test suggestions, talks about operational hardening and using Key Vault and some of these other features to lock this down, make sure that my application is not just functioning, but is secure from an organizational perspective. So I wanted just to show you that as an example to get in and take a look at Copilot as a way to expand your learning, take something we've talked about in here, and then go back into your production environment and maybe use Copilot to actually implement some of these solutions. Okay, so we've created the Azure function. Let's go take a look at this. A lot of the same things that we've seen in other Azure resources. It's going to come back and give me all the information in that overview page. But I want to focus on some of these subcategories down the left-hand side of the blade. Now, you can actually have multiple functions in the same Azure Function app itself. So you can have multiple functions in here, very similar if you take a look at an app service plan with multiple app services that are in it. But an Azure function, I'm going to consider it having one that I can take a look at some of the app keys. I'm going to get into my deployments, take a look at my deployment center. This is where I'm going to get my code to actually deploy into the Azure function itself. Remember, the Azure function as an app is just the space in which your code is going to run. In my example that we've been using in this recording, this is where I would take that code snippet that Copilot gave me for my LUN algorithm. I could post that into my GitHub, and I could then pull that into here and have it post that information or publish that information into my Azure function. Taking a look at some of the settings, this will be familiar if you took the recording on Azure App Service Plans. We have environmental variables, we have configuration settings that you're working with that you can now pass off environmental variables in app settings and connection strings that you now can pass to these applications, especially if you're working in an app service plan where you have deployment slots that you can now control these as your application, or in this case, function, moves through development into testing, into QA, and into production itself. So a lot of that same kind of infrastructure. It's not really talked about in the course, but here's that durable function piece that I talked about, which is a way to take multiple applications, in this case, multiple functions that you're working with, and making them durable. And we have a number of different patterns. If you do go to the Microsoft Learning site and do a search on durable functions, it will talk about a fan out and a fan in, and a man in the middle, a timed interval. So they talk about all these different patterns in which to create a durable function to be able to take information and pass it, in my example of, yes, pass in a triggering activity for a numerical value that does the LUN algorithm and validates it. It's now got that value of 40 in my social insurance number. I got to take that number, I got to pass it to the triggering activity of another application function that is running, and it's now going to be triggered to now tell me where that came from and potentially have multiple features that could fan out and do a number of things with where it came from using that information. So all of those characteristics now I have available for you through the Azure portal, CLI, or PowerShell, or other ways to interact with Azure. You saw this a few minutes ago when I went into the plans themselves and you pick them out on the graphical interface in the portal, but here's that table that talks about some of the values. In this case, it's going to be the default timeout values of the functions themselves. And again, from an iWinky moment, you might want to remember some of these of, you need to have something that's going to have a maximum runtime. And if you have that maximum runtime of 10 minutes, that means you're going to go to a consumption plan. When you take a look at the scaling, and with the exception of the function app that goes into the app service plan, which scaling is going to then be controlled by the app service plan itself, we can now actually scale this from 0 to as many functions as that consumption plan that you assign it to is going to have available to it. Now, function apps, very small, spin up very, very quickly and will scale up very, very quickly. Now, you can actually have that scaled to 0 capability. You can actually have a cold start where you start with none and it's going to have to spin that first one up. Or do I have one instance already going so that from there, if I need to scale up my function, I can then have one already running. So it's a warm start as opposed to a cold start. Taking a look at that scaling behaviors, again, this becomes one of those charts you may want to remember from an exam perspective. What number of scales can we work with? The number of instances you're dealing with? How often does it scale? Do you have manual scaling or automatic scaling that's available? Or is it just event-driven scaling that says once that function is being used and you need more of them, it will then automatically trigger the build of a new instance of the function, as you see in that consumption plan. So there's an introduction to an Azure function. Let's do a quick module review. Which Azure function hosting plan is best when predictive scaling and cost are required? So I need to have predictive scaling and predictive costs. If you want to go ahead and pause the screen. The answer for that one would be the dedicated plan that has the predictive scaling values that you can now go in and scale based around a criteria that you define, as well as has predictive costs that you're dealing with. Question number 2, which serverless workflow would you choose if a solution requires a design-first development model? Go ahead, pause the recording for a second. This goes back into the conversation that we talked about that had the Azure Logic Apps versus Azure Function Apps. Function apps are typically code first that you're dealing with. And I mentioned in the Logic Apps that you had that drag and drop, that low code, no code. So this would be the comparison to a Logic app. So we've introduced the idea of what an Azure function is, as opposed to your app service plans you're working with. It is a platform as a service environment that allows you to take microservice code that is typically these one-to-one. Now remember the difference between an Azure function, that one triggering activity. It could be a time-based trigger or some event-based trigger, but there's only one of them to perform an activity. Now, I would recommend that your function itself does one and only one thing. In our case of the LUN algorithm, it's only going to validate if it's a valid number. Now, it can have multiple input bindings, and it can also have multiple output bindings. And you'll see that coming up in the next module. Now, an input binding says I need to get information from a number of different sources. I can pull all that input value in, do something with it, and maybe I need to put that information into one or more locations. That's going to be your output bindings you're dealing with. So that's the end of module number 1 in Azure Functions. Thank you for joining this recording, and I look forward to seeing you in another recording.